Right now, we continue with example 2 from previous semester papers, semester November 2005, question to be 6 marks. Okay, the question is, if y the power of 4 equals to tangent x squared plus y squared plus e the power of xy, find dy over dx by using implicit differentiation. Right? Okay, first step, we can define one by one. Right? We define y the power of 4 equals to a, and then we define tangent x squared plus y squared equals to b, and we define e the power of xy equals to c. Right? Okay, after that, we differentiate one by one with respect to x. Right? Okay. First, we differentiate a. Okay, when we differentiate a, it becomes a prime. And then, to differentiate y the power of 4, we can use power rule. Okay, so we can move power to the front. So we have 4 here, y, and then we minus 1 from the power of 4 here. So we have y cubed. Okay, and after that, we differentiate y. So we have dy over dx. Alright, so our a prime equals to 4y cubed dy over dx. Alright, then we differentiate b. Okay, we can use trigonometric rule because we have trigo function here. Okay, so we differentiate b, it becomes b prime. Okay, and then to differentiate tangent x squared plus y squared, we can refer formula derivative of tangent single x, which is equals to sec squared x. Okay, so now we just assume our x here equals to x squared plus y squared. So when we differentiate tangent x squared plus y squared, it becomes sec squared x squared plus y squared. Okay, this is composite function. Okay, function x squared plus y squared is an inner function or the function inside tangent. So we need to use composite rule. Alright, composite rule means we differentiate outer function first and then we differentiate inner function. And in between must multiplication operation. So after we differentiate outer function, okay, now we differentiate inner function. Okay, inner function is x squared plus y squared. So when we differentiate x squared plus y squared, we can use sum and difference rule. Means that we just differentiate one by one. So when we differentiate x squared, it becomes 2x and then plus. When we differentiate y squared, it becomes 2y dy over dx. Alright? And after that, every time when dy over dx inside bracket, we must expand. Okay, because the final answer, we need to write dy dx as a subject. Okay, so we expand sec squared x squared plus y squared times 2x. Alright, so we just put 2x in front and then sec squared x squared plus y squared. And then we expand x squared sec squared x squared plus y squared times 2y dy over dx. Okay, so we have plus 2y dy over dx sec squared x squared plus y squared. Alright? Okay, this is b prime. Okay? Okay, and then we differentiate c with respect to x. Okay, we can use exponential rule. Okay, because this is exponential function. Okay, so when we differentiate c, it becomes c prime. Okay, and then to differentiate e, the power of xy, okay, we can refer formula derivative of e the power of single x. And we get back e the power of single x. So, when we differentiate e the power of xy, we will get back e the power of xy. Okay. But after that, we need to differentiate inner function xy. Okay. We need to use product rule. Okay, because this is multiplication function between variables. Alright. So when we use product rule, the formula is vu prime plus uv prime. Okay. So our u is x, then we differentiate, we have 1. Our v is y, then we differentiate, we have dy over dx. Okay. And then we substitute here. So we have c prime equals to e, the power of xy. We replace vu prime here. Okay. We multiply v times u prime. So multiply y by 1. Okay. So we have y here. And then plus, we multiply u by v prime. So we multiply x by dy over dx here. Alright. And again, our dy dx inside bracket. Okay. Okay, so we need to expand. Okay, because the final answer we need to write dy over dx as a subject. Alright. So we expand e the power of xy times y. So we have c prime equals to y e the power of xy. And then we expand ex the power of xy times x dy over dx. So we have plus x e the power of xy dy over dx. Alright. Alright, after we differentiate one by one in the previous slide, okay, we refer from the given question, y the power of 4 equals to tangent x squared plus y squared plus e the power of xy. Then we differentiate implicitly with respect to x. Okay, and then we substitute one by one. Okay. Okay, from the previous slide, when we differentiate y the power of 4, we have 4y cubed dy over dx. So we replace here. And then equals to, okay, when we differentiate tangent x squared plus y squared from the previous slide, okay, we have 2x z squared x squared plus y squared plus 2y dy over dx z squared x squared plus y squared. Okay, so we replace here. Okay, and then plus, from the previous slide, when we differentiate e the power of xy, we have ye x the power of ye the power of xy plus xe the power of xy dy over dx. So we replace one by one. Right? And after that, we separating the term containing dy over dx and not containing dy over dx. Okay. Now we have three terms containing dy over dx. 1, 2, and 3 here. Okay. So let's say we bring all terms containing dy over dx to left hand side. Okay. So we get this. Okay. We have 4y cubed dy over dx. This is plus sign. When we move to left hand side, it becomes minus. Okay, minus 2y dy over dx z squared x squared plus y squared. And then this is plus sign. So when we move to left hand side, it becomes minus x e the power of xy dy over dx. Okay, so the term containing dy over dx we put on the left hand side, let's say. Right? You also can put term containing dy over dx on the right hand side. Okay. Alright. And then after we bring the term containing dy over dx to the left hand side, so now on the right hand side we have 2x z squared x squared plus y squared plus y e the power of xy. Right? Okay, after that we factorize dy over dx. Okay, So now we have three terms containing dy over dx. So we factorize dy over dx. So in bracket we have 4y cubed minus 2y z squared x squared plus y squared minus x e the power of xy. Okay. We factorize dy over dx on the left hand side. Okay, so we still have the same function on the right hand side. Okay, and after that, the final step, we need to write dy over dx as a subject because the given question, from the given question, we want to find dy over dx. Alright, so our dy over dx equals to, we move all term in bracket to right hand side. Okay, this is multiplication operation. So when we move to right hand side, okay, it becomes division function. So now we have dy over dx equals to 2x z squared x squared plus y squared plus y e the power of xy over 4y cubed minus 2y z squared x squared plus y squared minus x e the power of xy. So this is the final answer. This is our dy over dx. Alright. Coming up next, example of implicit differentiation from previous semester papers. Thank you for watching. Stay tuned. Bye. Assalamualaikum.